solve this today's LeetCode problem. This is LeetCode, an easy one. Find center of a star graph. Let's see what the question is. So we have given an undirected star graph consisting of n nodes labeled from 1 to n. A star graph is a graph where there is a one center node and exactly n minus 1 edges that connect the center node with every other node. You are given a 2D integer array ages where each asi is equals to ui comma vi indicates that there is an edge between the nodes ui and vi. Return the center of the given star graph. So basically the question is asking for that which node is the center node, right? And we have only edges present from center to each node, right? So if you see, we there is an edge from one center to each other node, and we just need to return the center of the given star graph, right? So basically, if you see in this question, edges are given from 1 to 2. So 1 to 2, there is an edge. It's a black. So if you see, if you observe carefully, so it's you will see this black edge. 2 and 3 is we have a given edge. 4 and 2 is also have edge. So the question is to just return, just return the center of the graph, right? So the first observation is that the center node will definitely present in all the edges, right? In all the edges, in all the pair of edges, in all the pair of vertices for a particular edge, in all the pairs of vertices for a edge, right? For edge, right? That's the observation. If you see here, the in particular one edge, one will 2 is present in this, 2 is also present in this, 2 is also present. So what does it mean? It means that it means that if we have if we just count the occurrences of all the nodes, all the numbers or nodes, or numbers from present in edges, and check that which node is occurring n times, n minus 1 times, right? N is number of nodes here, n is the number of nodes here, and n minus 1 is edges. So we will check that which node is occurring n minus 1 times, right? Which node is occurring n minus 1 time, and then that will be definitely our center center node, right? That's the Because that's the easy problem, right? And you observe also that for being a center node, this node must be present in all edges, and that's how this being a center node, and that will how it connect to each and every node. So we will just count the occurrences of we will just count the occurrences of all the nodes, and check that which node occurs n minus 1 times, in my edges, and that would be the center node. Because for connecting because there are total n minus 1 edges, so total occurrences would be also n minus 1 in particular edge, right? So that's how we will solve this question. So we will just count all the occurrences. Let's suppose this is 1 and 2 given, 1 and 2 given, and this is 2 3, and again this is 4 and 2, right? So basically what we do, we will just count for each and every number. One count is 1, 2 count is 3, 3 count is okay, 2 count is 3, 3 count is 1, 4 count is 1. So basically if you we will check the count of each numbers. So you will check that 2 count is 3, and also the number of edges is 3, right? Also the number of edges is 3, and 2 count is also 3. It means 2 is the 2 is the center node, right? 2 is the center node. So let's just implement it, because it's a very easy problem. I hope you have solved it, right? If you are regularly solving it and you have practice, so you will solve it. So let's suppose this is take an edge is a dot I. So n is the number of nodes, right? So for do not confuse it. Let's take it as am, right? Because n is given as nodes, and we don't have nodes, right? We have only edges list, and that's enough for us, because we do only need to find the occurrences as much edges present, right? So what we will do, we will take an ordered map to count all the numbers, and we will just I will just iterate in this ages, right? This is a pair given. So this is a 2D array. Ages is 2D array, two vertices. So I need to insert both of the numbers in my map for counting purpose. Now I will iterate in map and check. What I will check, that if my count, my numbers count, occurrences of count is equals to m. If it is equals to m, it means this would be definitely for sure it is a center node. Otherwise, if I don't get, I will return -1. That will not happen, because it is given that it will be always represent a valid star graph. So this will return always from here. So if the count is m, it means it would be definitely a center node. And this is how we will solve this question. Let's just run it. We pass the sample case. Let's submit it. Yeah, we have passed. So what the time complexity would be? So time complexity would be, I need to iterate in whole of ages, and also I need to iterate in whole of numbers. So that would be O of n is the number of nodes, and also this mp can be mp is also O of n, right? So ultimately O of n-1 is ages, plus O of n is number of nodes. That would ultimately is equals to O of n, right? And is the number of nodes here, and is the number of nodes here, and is the number of nodes, right? And the space complexity would be again O of n, because we are checking occurrences for each and every nodes. So that would be O of n. So this is how we'll solve this question. But now the question is, do we really need to count for all nodes? Can we optimize it further? Do we really need to check the occurrences check the occurrences for all the nodes, right? For all the nodes, right? Do we need to check? So if you observe here, one line here, the question is given that one center node and exactly n-1 edges, and that connect the center node with each and every other node, right? It means if the center node is connected to each and every node, so it means the center node would definitely present present in all the edges. I'm sure about that. On all the edges, I'm sure about that. So why don't we check for all the nodes? Why wouldn't we check only two edges, right? Why we are checking for two edges? Let's suppose I take 2 3, and I take 4 2, right? I take 4 2. So if you see here, this 2 3 and 4 2 both have 2 present in their vertex, right? So what I will check, I will just check which number is common between which node is common between two edges, and I'm sure about that the number which is common, I'm sure about that the number which is common in both of the edges, that would be definitely definitely be my center node. Definitely my be my center node. That would be definitely my center node. How I'm telling, because each and every edge, for a center node, each and every edge would definitely contain a center node. And if it is a common node, if there is a common node between two centers, it means that would be definitely my center node, right? Because both edge is different, and both edge is uh, is pairing two different vertices from center node, right? So the common vertices which will be happen between these two edges, that would definitely be my center node, right? So how we will check? So we will check that suppose let's take it as a first and this is second, right? So how will I check? I will check the first element, which is 0, if it is equals to my second element, or either this two or this two this can be equal, or which can be equal, or the first 0 and second one can be equal, right? Either this two can be equal to 4, or either this two can be equal to 2. If any of this condition happens, if any of this condition happen, it means 2 will be my center node, because first is equals to any of these two nodes. It means first will be my center node, right? Center node. Otherwise, if if this don't happen, if this don't happen, it means definitely my first one. It means if above condition is not valid, satisfied, is not satisfied, then first one will first one will be my center node, will be my center node. How am I saying that? See, I'm sure about that. At the some a single vertex will be common in both of the edges, right? If my first value, suppose this, if my first node is not common with any of these two elements, it means my second element will definitely be uh, common with my elements. Suppose here it is given 3 comma 2, so this 3 is not common with 4 and 2, but if this 3 is not common with 4 and 2, I'm sure about that the second vertices, which is 2, will definitely be common with between any of these two vertices. So that the second will be, if the first condition not satisfied, I'm sure about that the first one will be my center node. So this logic will be applied to solve this problem. And how many what it's take nothing, it just take two checks. It's just take two edges and checks a single line of checks, right? So what does time complexity would be O of 1 and space be O of 1, right? So just you don't need to iterate in whole of this, you just need to check for two edges, the first and the second edge. And we have given that we have n nodes and n minus 1 edges, so 3 nodes is the minimum, so two edges will be the max, the minimum edges which will be present here, right? So we don't need to iterate in, or we don't need to iterate in this. We just remove this. What we will do, we will check for the first node and the second node. How we will do that? Let's see that. So what we will do, we will check that whether edge is 0, 0th element is equals to 0th element, sorry, 1th element, 0th part, right? So what does it represent? It represent the first and the second, or let's just take that is the first and second, right? So this is a vector in first, and this is ages 0. This is just to show you, so this is just for an easy purpose to show you, right? So second, and this is ages 1, right? So this is the first and this is the second. So instead of this ages 0, I can write it first, or instead of this ages second, I can write it second. So this is first 0 and this is second 0. And if it is equal, or what the condition can be equal, first 0 which can be equal to second one. And if both of the conditions either this condition satisfies or this condition satisfied, in any of the case, the first 0 would be our center at a center node, that would be my answer. Otherwise first one will be definitely be my answer, right? I will return first one. So either this condition satisfied, or this would be definitely valid if this not satisfied, right? So that's how we will solve this question. So instead of this taking vector, you can just write it like ages 0. You can just write it like ages 0, right, in this and in this also, and you can replace it with age 1 if you don't want to take an extra add, right? And this is ages 0. this is ages 0, and this is ages 0 1. So you can just replace it by both is same, right? Just run it. We have passed the sample case. Let's submit it. This is the same thing, right? This is the same thing. Just to give you imagination purpose, it's I have used first and second, but it's the same thing. You can write without it. So what is the time and the space complexity would be? Nothing. O of 1, because we have used only if conditions. So O of 1 time and space is O of 1, because we haven't used any spaces. So we have O of 1, and the space is also O of 1, right? So this is how we will solve this question. This is just an observation. You can solve it from O of rotating in whole to O of 1, right? So thank you so much. Hope you liked it. Bye bye.